These are the examples from 4-3, the multiplication rules and conditional probability. My first formula is the multiplication rule for the independent events. So if A and B are independent, the probability of A and B is equal to probability of A times the probability of B. My first example is 4-23. I have two events. I have a coin flip, and then I have a die is rolled. Find the probability of getting heads on a coin and 4 on a die. So the key word here is the word and. This is how you know you're talking about a multiplication rule rather than an addition rule. Find the probability of getting heads and 4 on the coin. So the probability of getting heads is 1/2, and the probability of getting a 4 is 1 out of 6. So if I need both events happen simultaneously, I will multiply. I need the 1/2 and I need the 1/6. The word and always will refer to a multiplication sign. In this case, I get 1 out of 12, which can be approximated to 0.0833. 4 decimal places will be sufficient. Next example, 4-24. A card is drawn from an ordinary deck of cards and replaced. So card is drawn and replaced. Then the second card is drawn. Find the probability of getting a king and then a 7. So I need the king and the 7. Now, the fact that this was replaced tells me that the events are independent events. Therefore, the probability of getting a king is 4 out of 52. The probability of getting a 7 is 4 out of 52. This does not change. All I need is to simplify this out and give a final answer. I'm not going to bother with fractions anymore. I am multiplying 4 out of 52 times 4 out of 52 on my calculator, and my final answer is an approximation correct to 4 decimal places. 0.00, I have 5, 9, and then a 1, so this is sufficient. Next example. What if the card wasn't replaced? Not replacing the card. How would this probability change? I'm still looking for the probability of king and a 7. So the probability of getting a king is still 4 out of 52, but still using the multiplication though, but the probability of getting a 7, so the assumption is that once I picked a card, I do have that king, as in I picked it. Now, there are still 4 7s in there, so that doesn't change, but the one thing that does change is the fact that I don't have 52 cards anymore. I only have 51. So now the probability has to be a conditional probability. And if I multiply these two together to 4 significant or to 4 decimal places, I have 0, 0, 6, 0, and then a 3. So it changes slightly just enough. So going back to some examples of independent events. It was found that 3 out of 4 out of every 4 people who commit a bank robbery are apprehended. If 3 bank robberies are selected at random, find the probability that all 3 of them will be comprehended. So this is example in the book. I'm not making this one up. And the probability of robbers comprehended happens to be 3 out of 4. So if I want 3 robbers comprehended, the first one is independent of the second one, is independent of the third one. What I really have is 3 out of 4 to the power of 3. So you can use your calculator and give me an approximation to 4 decimal places. Technically it's an approximation sign, but it is not wrong to put an equal.